Hello, folks. This is Miss Roll with our PNE Notes. This is on our subatomic particles. So first of all, what is inside of an atom? Inside of an atom, we have these things called subatomic particles. Basically, it just means the stuff that's inside an atom, right? Subatomic, inside an atom. And so though we have three different particles in there. We have protons, neutrons, and electrons. PNE, proton, neutron, electron. We like to shorten it. Protons have a charge that are positive charge. Neutrons do not have any charge. And electrons have a negative charge. Later on, we'll get into why this all becomes important. As far as mass is concerned, both protons and neutrons have a mass of 1, because it's measured basically in the mass of a proton. Whereas electrons are so tiny and light, they have 0 mass. Okay, so electrons don't really contribute to the mass, only the protons and neutrons. Finally, the location. The protons and neutrons both live inside of our nucleus, which is the mass in the center. And the electrons are kind of floating around that nucleus in energy levels. So what is the structure of the atom? I'm going to move my picture again. So the structure of our atom starts off with the nucleus, right? Where I mentioned that the nucleus is the center of the atom, right in the center. The nucleus contains all of the mass of the atom. So we said only protons and neutrons have mass, and they are the two things that live in the nucleus. Okay, so that's where all the mass for an atom is. And then the protons and neutrons, like I just said, are located in the nucleus. And then there's this electron cloud or energy levels. We'll call it a few different things. And these are outside of the nucleus. Nucleus in the middle, these are outside of it. They contain the electrons. Oops, let me go back. And so they contain the electrons, right? So nucleus is in the center, and then around it, we've got this electron cloud or energy levels, where our electrons are kind of floating around, running about. How to read our periodic table. So, first thing you need to know is each square on the periodic table has a ton of information. So the atomic number is the number of protons in the atom, always. That's what that number means. So each atom has its own atomic number. This is like a fingerprint. Okay, it tells you exactly the number of protons. That is usually at the top or like the top left of the periodic table square, like in the picture. Then we have the atomic mass, which is the average mass of all variations of an atom. So we'll talk about what those variations are at a later point, but just know the atomic mass, the number on the periodic table, is this average of those variations. So that's why you'll see these like decimal points. And then the mass number, so these are two different things. We'll have to make sure. Atomic mass, mass number, two different things. But the mass number is the sum of protons and neutrons in an atom. Okay, protons plus neutrons in an atom. We also can get to the same number by rounding the atomic mass. Okay, so for example, on this square, we've got atomic mass of 12.011, which we would just round to 12. So that tells us the sum of protons and neutrons in carbon is 12. So identifying PNE from our periodic table. So protons are just the atomic number. That's the fingerprint. That's the thing that identifies the atom, protons. So in the picture there, 11 is our atomic number. That's the number of protons in sodium, always. If it's 12, it's something different. If it's 10, it's something different. The electrons we have is the atomic number as well. So the electrons are also the atomic number in a neutral atom. So like I said, there are some variations. We'll get to those at a later point in time. And then the number of neutrons is the mass number minus the atomic number. So remember we said that the mass number is our rounded atomic mass. So down here we've got 22.99. That's our atomic mass, and we would round that to 23. So our mass number for sodium here would be 23. And we subtract the atomic number of 11. 23 minus 11 would give us 12 neutrons. Okay, Okay, so this is where that atomic mass versus mass number, we really got to know that difference to find our number of neutrons. All right, that is it for our PNE notes. Remember, I highly suggest that you go on to the PNE examples video, but of course that is your choice. But make sure you've got these in your notes and be ready for our practice.